I'd like to start, so please sit down. And we are already late, so I got 10 minutes or a quarter of an hour extra. So there's no problem with running late, but anyway, I'd like to start. Well, welcome to diving deep into TWIG. This is a talk about TWIG internals, actually. And first, I will talk about ways to extend TWIG or to add your own functionality. And then I'd like to talk about the way that TWIG knows how to render your template. So you write a template in the language TWIG, and the result is an executable PHP template. So we are taking a look at the journey from TWIG to a compiled PHP template. My name is Matthias Noback. I am from Holland. I live in Zeist. Maybe you know the place. I live there with my family, my girlfriend and son. And in March of the coming year, we will have a little feature addition to the family. We will have a little girl then. So I'm very happy about that. I started in... oh, thank you. I wasn't expecting that. 10 years ago, I started as a freelance web designer, and many things happened from then. I have been employed as a web developer at several companies during 6 years, and now finally I am back in the business as a self-employed developer, consultant, advisor, trainer. My company is called Noback's Office, but you may know me from my blog, PHP and Symfony, or from Twitter, or even better, you may know me from my book, A Year with Symfony, a well-received book. You can still buy it, of course. So visit leanpub.com/A Year with Symfony to read more about it. Well, these are some nice quotes from very kind people about my book. But something else today, TWIG. TWIG was originally developed as a Python library, a Python templating engine called Jinja in 2006 by this man named Armin Ronacher, or well, I don't know, maybe it's Armin Ronacher or Armin Ronacher. Somehow, finally, he ported Jinja to PHP to use it inside a PHP project, and he already called it TWIG. This was in 2008. And a year later, Fabien stumbled upon it. He was looking for a Django-like templating engine with a syntax like Django. And he was looking for a flexible and very fast templating engine. And well, he found TWIG. He started hacking on it, as he called it, on his blog. The rest is history. We know TWIG has become more or less the standard templating engine for Symfony 2 projects. So an overview of my presentation today. First, I will give a short sample of what TWIG can do, so that we know we talk about the same things here. Then I will show you TWIG extensions, and then there are a lot of difficult words, so to say: LEXER, parser, token parser, node visitor, and compiler. We will all discuss these concepts and see how they together work on creating an executable template based on a TWIG template. So first, the TWIG samples, and this is what you will see inside a TWIG template. I wonder, do you use TWIG on a regular basis, every day maybe? Well, that's great. So I don't have to explain everything about it. So you will recognize this syntax. It has accolades and percentage signs. Just to be sure that we're talking about the same thing, the first thing you see here is a block, a tag block. It starts with an accolade and a percentage sign. Then comes the forename, and a lot of different things. It doesn't really matter now. But the second line is a variable block, a so-called variable block, starting with 2 accolades and ending with 2 accolades. And basically what is in between these accolades will be echoed as part of the template. Then finally another block, a tag block, which is the end for block. This is what TWIG functions look like. You will see the first example shows the random function. It takes a random element from an array, happy or sad. So we don't know, or maybe you don't know if I'm happy or sad at this moment. Well, I'm happy to see you. So The second function is the range function here as an example of a function which takes two arguments, the beginning of the range and the end of a range, and it gives you an array containing elements from 1 to 20. Then the third example of a function would be the cycle function, a very nice function to cycle between two values, in this case odd and even, based on the index that is given as the second argument. Then there are filters. Filters take what is in front of the pipe and do something with that. So capitalize, for example, would capitalize the first letter of the user's name. The first filter would take the first element of the phone numbers array, and the join filter would combine the elements in the tags array and put a comma in between them. Then there's tests. You may not have even noticed that you are using tests in your TWIG template. That is because everything that comes after the is a test. So if expiry date is defined is a test to check if expiry date is indeed a defined variable inside the template. And empty is also a test to see if an array contains no elements. Well, in fact, empty is just the PHP empty function. And is odd, for example, is a nice test to see if a value is an odd value. Then there are tags. As I already mentioned, a tag is the first thing that is inside a block. So when you see an accolade and a percentage sign, you will recognize the tag by the fact that there stands a little word if, or in this second example, block. Maybe include. There are many more. You have the for tag, the macro tag, the include tag, the extends tag, well, many tags. One of the questions I had first when I was using TWIG was how can I add these functions myself, these filters, these tests maybe. There is a very easy way, which you already may know, which is to create an extension class for TWIG and to implement some functions of this TWIG extension interface. Who has written a TWIG extension already? Well, also, many people. That's good to hear. So you already know how to register a function or a filter. Maybe a test. I think there are more TWIG filters and functions in the world than there are tests. And I think that test is a really good way to clean up your template and reduce all the expression logic inside your conditions. So let's see, well, you already may know then that if you have created such a class, a TWIG extension class, you need to register it. The old school way would be to call add extension on the TWIG environment, but with Symfony, of course, you can create a service for it and use the twig.extension tag. Well, this is what it looks like to register your own function inside a TWIG extension. You return an array inside the getFunctions method of TWIG simple functions. This is a nice class wrapping your function. And you see that the first constructor argument would be the name of the function you'd like to create, and then the second argument is the callable that should be used as the TWIG function. And you see that it works like any normal function. So in the example template below my function, quote computer, computer will be the thing argument of the my function. So this is already pretty nice. Adding a filter looks very much like adding a function. In fact, a filter is a function. Only difference is that the thing that is before the pipe in the TWIG template will be automatically the first argument of the function. So in this case, the thing variable will end up as the what parameter of the mine filter. And the extra argument, false in this case, will end up as the second argument of the mine filter. Then adding a test is also very easy, so go add some more tests to your TWIG extensions. This is a sample test, it's called a conference, and with it you can check if something is a conference. So in the example, if SymfonyCon is a conference, well, I told you so. Then you can put anything inside this callable that you like. You can even delegate the function to any service you like. The possibilities are endless actually. There is also a more advanced way of extending Twig, that is to create your own tags. And this needs some explaining, because there is a lot of things going on in the background when Twig is trying to compile a template. So we will first take a look at the entire process from loading a Twig template to compiling it, and then you will see somewhere in between where you could add your own tags. So loading a template. Of course, with Symfony, you don't have to load a template yourself. You can just say on top of your controller, add template, and it will find the template automatically for you. But when you would use Twig standalone, this is how you could instantiate the Twig environment and then render a template, where first you have to set a loader. You need to tell Twig where to find template files. And then you fill a context array, which is basically the array of template variables. And finally, you can call the render method on the environment with the name of the template and the array of template variables. Now, what is then a template? that's a good question. Inside this Twig environment, we will see that the render method basically loads the template based on its file name, and then it calls render method on the template. So a template is in fact an instance of a class or an object. It has a render method, and that is why you will see that a template class implements the Twig template interface. So the result of the load template method would be such an instance. And then calling render on it only requires an array of template variables. And this is what a Twig template looks like when you would open it in its compiled form. Maybe you've one day taken a look inside your Symfony projects in the app cache environment Twig directory. This is where you will find all the compiled templates. And it's not very readable, but it's fast enough to render a template, well, very fast. So now we are going to take a look at how Twig decides that the result should be this instead of something entirely different. And so somewhere in the process, conversions like these are happening. When inside the Twig template there is a paragraph and a variable name, then the result will be echo this paragraph and check if the name variable is inside the context. If not, it will be null automatically. You will also see that Twig adds escape filters automatically to any variable. So, well, somehow, somewhere, this step is taken from raw template data to executable PHP. Well, of course, the first thing Twig does is retrieve the template source from a file or from something else, and that's also possible, but in most cases a file. And it then compiles the Twig source to PHP. And this is a very interesting concept. I was very fascinated by this when I first found it out, that there is a very big process from a raw Twig string to actually a PHP template class. So, and you will know everything about it after this presentation. The first step in compiling something is always calling a LEXER. And maybe you know something about compilers or processes that convert strings in some language to another language. Like compiled languages also have LEXERs and parsers and compilers to convert, for instance, C to machine language. Right, so the same thing happens here. Twig has to be compiled to something that PHP can execute. And the first step would be to call the LEXER. And the LEXER, and this is somewhat theoretical, matches a given input string, like a Twig template, against certain patterns it knows. And these patterns are called lexemes. And for each of the things it recognizes inside the input string, it creates a token. And in the end, it returns a stream of tokens. So it basically splits up the input string in things it knows. And this is how I like to explain a LEXER. Maybe you recognize this? Who knows what this is? Or maybe it's too small to see. Lego, right. It is on every Lego box all over the world. It says, warning choking hazard, small parts. And because I'm a Dutch person, I only recognized waarschuwing, verstikkingsgevaar, kleine deeltjes. And maybe you are from a different country and you will recognize some other line in it. But still, you would be able to take any other line of this text and recognize the fact that there are words in it, there are spaces, there are exclamation marks, there are dots. So you would be able to lex this string. You would be able to chop it in pieces that you recognize. So some words, some separators, some punctuation. And even though you don't know the meaning, although you could guess the meaning of all these sentences, there could be something entirely different written there. But you would still be able to chop it in pieces, but not understand it. So everybody has lexers in his mind for most of the Western languages, I think. So I already have problems with the Eastern languages here. I would not be able to recognize where a word ends. Maybe each character is a word, or I don't know. But for many European languages or Western languages, I would be able to lex these input strings. Now, TWIG has, of course, certain patterns it recognizes. And you would have guessed these are the markers it will look for. The main markers are, of course, the accolade and the percentage signs, which mark the beginning of a block, and the double accolade sign, which marks the beginning of a variable block. I didn't previously mention the comment block. I almost never write comments in my TWIG template, but if you want to, you can do it, and TWIG will recognize the fact that it is a comment and strip it out. Well, the lexer then takes all these basic positions as the start of each block type, and while it's validating some basic syntax rules, it collects tokens for each part it recognizes. And these are the different token types TWIG would recognize. First of all, of course, the block start, which is an accolade and a percentage sign, and the block end, which is the reverse thing, variable start and variable end, but also raw template data. It does nothing with that, it just keeps it in memory to be later echoed inside the PHP template. Then names, like for and if. Numbers, it keeps in a separate token. Strings also. Operators, punctuation. There are some more, but these are the most important ones. And each token will have one of these types. It will have a value, which stores the original string that was found in the TWIG template. And it also keeps a line number for debugging purposes, since in the process many things will change, and in the end you may not know where a given error was made. So the line number is kept to give you nice error messages. Well, let's take this very concrete template, something you will never write in your daily job. It starts with an end if block. So of course this would fail. But my point here is that it would not fail in the lexing state. So when the lexer is trying to interpret this, the input string, it just recognizes the start of a block, the accolade and the percentage sign. And then it recognizes a name, end if. And then it recognizes the end of a block. It doesn't care about whether this is meaningful or not. It just splits the original input string. This is something you can do at home using TWIG. So take the environment and get the lexer from it, and then ask the lexer to tokenize a given template string. And tokenize means give me the token stream for this input string. And the good thing is you can echo the token stream. It has toString methods, and each token also has a toString method. So in the end, you will see a long, nice list of each token that is found inside the TWIG template. So first of all, as I already mentioned, the block start a name, and it keeps the name and if inside it. A block end, a text. Text is some raw template data. It does nothing with that. It could have also been an empty space, or maybe some JSON formatted string or anything. TWIG doesn't care about if the template file is HTML, or that doesn't matter here. It just keeps the raw template data inside one token. Then it recognizes the start of another block and a name for. Then another name item, an operator in, another name items, and the block will end. And so on and so on. you would be able to do this. This is a simple exercise you could do by just looking at the code, and by knowing the token types, you could just collect the tokens and write them down. Well, to keep track of what the LEXER is doing, it keeps a stack of states. So at each point when it's lexing through this input string, it will be in a certain state. And the first state it will be automatically in is the data state. So it will expect some raw template data at the beginning. And whenever it meets the start of a block, an accolade and a percentage sign, it will go to the block stage. And there are some rules for each of the stages. For instance, you cannot go into the block state once you're in a block state already. You can only get out of a block state and back into the data state. And this is what these states would look like for this this example template. First we are in the data state, then we go to the block state, and when the block ends, we go back to the data state, again to some block for the block 4. And while we keep processing names inside this block, we keep in the block state, and then we go back to the data state. And you will see that once we are with the double accolade sign, we will enter the variable state. And in the end, we will go back to the data state. So for example, you could not stay in the block state at the end. You always need to close the block before returning to the data state. And this is also why a TWIG has, in the LEXER LEXER phase, I would say, it checks syntax. So some very basic syntax rules. It would be impossible to start a new block once you already have a block. It would also be impossible to end a variable block without closing any open brackets. Also, you should not close anything before you open it. Well, these are some pretty stupid rules, but well, you must have seen some syntax errors in the past when you just made a simple mistake inside one of your templates. The LEXER also checks for invalid characters or unexpected characters, and comments should be closed. Then, as I already mentioned, the resulting list of tokens that is collected from the input string may not be semantically correct. So the tokens collected may mean nothing at all. TWIG may have recognized certain parts in the input string, but once you would like to execute the template really, it would not make sense. Like in this case, starting a template with and if would eventually fail, but not at this phase, in this phase. So there has to be made a step from syntax to semantics, which means meaning. Semantics is about meaning, the meaning of this template file, and the intent you had as the writer of it. And this is what the parser is for. So the parser takes the token stream and it builds a tree of nodes called an abstract syntax tree for the template. And this tree of nodes shows fully the meaning you had when you were writing the template. And it removes any ambiguity from the template. So again, you can use the parser from the environment. You call get parser and you have the parser. Then if you already have a token stream available, you can just parse the token stream. And the result will be a node tree. And also, the node tree has nice toString methods, and so do all the other nodes have. So, well, you can just echo it, and you will get a nice print like this. On the left side, you will see the output of echo node tree. You'll see a module node, a body node, and inside each of these nodes, specific nodes, which stand for different parts of the input template. So first of all, you will recognize the text node containing data UL. And then the for loop starts, first with a temporary variable items, and inside the for loop you will find a target item and another temporary name items. I've also drawn a little diagram for this, so that you can see that what it means to create a tree of nodes. And when you follow it, you will see that that every meaning is conveyed inside this tree. So especially interesting is that the for node collects everything it needs. It knows its target variable, which is item. It knows the sequence variable, which is items. And it has a body, which is between the for tag and the end for tag. And inside this body, you will find the raw template data list item. There is also a filter to be executed, and there is another raw template data, the ending of a list. And the filter consists of two things, the name of the variable that should be filtered, which is item, and the filter name itself, which is capitalized. So this is already something you can read, and you can check if this this conveys the intent you had with writing this template. So the root node after the parsing process contains everything that is known about this template. It contains the body nodes. It contains the collection of blocks that is defined inside the template. It also has a link to a parent template if you use the extends tag. It also has the macros that you have defined inside the template. Maybe you have used another template. Well, that's also inside this root node. Well, the parser takes this token stream, and upon different types of tokens, it would create different types of nodes inside the node tree. And when it arrives at a text node or a text token, it will create a text node. It just conserves the raw template data that was inside the input template. When it sees a variable start, as you may remember the double accolade, it parses the expression that follows and expects an var end token. When it sees a block start, it expects a name like for or include extends, and then it calls a subparser for any of these specific names. So each of these names has its own parser. And a subparser is actually what some of you may know as a token parser. It is possible to add token parsers from within your TWIG extension. And each of these tags, these are some examples, the for, include, set, may define its own rules for parsing. So you can have just a name, but you can also say, well, I expect first a name, as in the case of for, I expect a name, which is for. I expect item, I expect an operator in, I expect another name, items, and that's it. So each token parser is entirely free in its own, so to say, syntax rules. And token parsers take the token stream as input and convert them to nodes that they want to be added to the tree. So let's take a look at how such a token parser would look like. This is a conference token parser. As you can see in the example below, we will in the end have a conference tag. It does nothing really interesting. You should really add some functionality to this to make it useful. But it's interesting to see that each token parser should have two methods, a parse method and a get_tag method. And so the get_tag method returns the name of the tag it supports, which is conference here. And the parse method, it inspects the token stream and tries to find the tokens it expects, and otherwise some exception will be thrown. For instance, if you have a for tag and nothing else following it, you will get an exception that your template is wrong. And in the end, the parse method should return a node, and in this case it will be a print node, which needs an expression node, and I have chosen here for a constant expression, which is the string SymfonyCon. Right, so at any place in the template where I've written this block with a tag conference, we will in the end, inside the node tree, have a print node, and inside the print node, an expression node. And we can check this. This is a sample template. There we go, conference. If we register the token parser, we can do it directly on the environment, but we can also use it. We can also register it from within our TWIG extension class, which is better, really. The only thing we need to do is echo the result of the parse function. And that will be again a node tree. And the node tree looks like this. So first, a text node with data, there we go. Then, as we would expect, the print node with an expression node inside it, and inside this expression the value is SymfonyCon. And again some raw template data, which is the exclamation mark. Well then, expressions are also have a dedicated parser, since they are quite difficult, so to say. Take a look at this expression 5 plus h times 4, something you may know from school. Yeah, what should we do first? Shall we first add 5 plus h and then multiply by 4? Or should we first multiply h by 4 and then add 5 maybe? This is something the TWIG parser needs to decide upon. So, and this is what we will see. We would expect here h times 4 is one thing, and then 5 plus that thing will be the result, right? Since multiplication wins from addition. But we need to verify this, at least during this presentation. So we echo the module node after parsing this template. And we will see that TWIG makes the right decision. So when we echo this expression, we will see that it has an add node. It's quite a long name, so TWIG node expression binary add. And then the add consists of a left and a right value. And the left is a constant node, which is 5. And the right part is a TWIG node expression binary multiplication. And the multiplication again has two parts, left and right, where left is a temporary variable name, which is h, and right is a constant, which is 4. So if we draw this in a diagram, we see that on top of this there is the plus operator, then left 5, right times and times is calculated for h and 4. So this is good. But how does TWIG know that it should be like this and not the other way around? Well, first of all, there's something called associativity. Most operators are left associative, which basically means that a plus b plus c should always be read as first a plus b and then plus c. So this will result in the diagram on top, where you can see that the lowest part is a plus b, and then that the result of that calculation will be used as the left part of the top plus. It should not be read as a plus and then b plus c, which can be seen in the diagram below. Then there is a problem with operators, and well, of course, some operators have to win from the other. So in the example a plus b times c, it should of course be interpreted as a plus b times c instead of a plus b times c. And this is done by using associativity, precedence. So each operator has a number indicating their precedence. Then finally, after the parser has taken all these token types and created nodes for them and created the entire tree, in the end there is the possibility for node visitors to change anything inside the abstract syntax tree, or to modify existing nodes, maybe remove some nodes, maybe add some nodes. This is very advanced stuff. You can really implement one yourself, that's no problem. Well, one good example is the auto-escaping node visitor. Since you may know that when you're using variables in TWIG to echo things, these variables will be automatically escaped for you. This is one of the great features of TWIG that, well, most of the times you don't have to worry about escaping for the HTML context. If your context changes, you have to think again. If you want to display raw data, you have to think again. But usually this auto-escaping node visitor will travel all over the node tree for a given template and add escape filters to any node that should have it. So that is very convenient, and this is really also, if you would like to implement a node visitor, you could do the same. You could travel all over the tree. For each node in the tree, you will receive a notification. Do you want to do something with this node? Maybe do you want to delete this node or add some other node? And this is pretty cool. For instance, Aesthetic has a node visitor to collect assets and calculate some things before compiling the template itself. Well, after all these nodes have been created, the final step would be to call the compiler. And this happens all behind the scenes, of course. So we have gone from an input string to a flat stream of tokens, no meaning at all, to a node tree with every meaning that was intended by the Twig template developer, which is you. And now we want to take this node tree and make it into some executable PHP code. And this is what the compiler does. All right, this is a summary of what I've shown until now, which is that nodes arrive from the parser, from the expression parser, which I told you about, from each of the token parsers and from the node visitors. So now every node is in place, and we can ask Twig to compile the source. And this is the function you can run at any time: environment compile source. If the template variable contains here a template string, the result will be something like this, as I already showed you, which stands for everything that was inside the original input string. Well, complicated as this may seem to convert a node tree to compiled PHP code, it is not complicated at all. So the compiler step is very simple. The compiler just calls compile on the module node, on the top node of the tree. And the top node itself calls the compile method on the body node. And the body node calls the compile method on the text node, and on the for node, and on another text node. So this whole tree will be compiled all by itself, actually. And each node knows which code it wants to produce in the end inside this compiled template. So let's take a look back at our custom token parser, the conference token parser. It returned in the end, after the parse method was finished, a print node. And we wanted it to become something like echo SymfonyCon. This is exactly what happens, because in the print node, the compile method does this. It retrieves the compiler as an object. It adds some debug info, like the line number, which is important for you when you get an error. Then it just writes some PHP code, in this case echo. It subcompiles the expression node, and then it echoes some raw data, or it adds some raw data, which is a semicolon and a new line. Subcompiling again means just calling the compile function of this expression node, but using the return value as to be put at that exact location in the template. So the result of calling echo and then, the result of calling this compile method will be echo SymfonyCon. Exactly what we wanted. Well, this is really cool. It is possible for you to put any PHP code you like inside each template. So when you create token parsers and your custom node types, it is possible to do some heavy calculations up front at compile time. And then the result you could put inside your template as compiled PHP text or string. Well, of course, when you run compile again and again, these heavy calculations may be done for each time you run compile, but usually in your production environment, for instance, compile is only run once for all the templates inside your project. So even though it will take some time then, after that, each of these calculations has to be run never again. The result will be stored as compiled PHP code inside the template class. Well, the only thing you have to create is your own node type and your own token parser, which can be quite a lot of work. Which is why you have to read the compile template a lot inside your cache directory. Usually inside Symfony projects, it's app cache environment/twig. When you're wondering what all these things means, when you have opened this directory, you will see random characters, which are the directory names, then another directory name, and finally another random file name. When you're looking for the compiled source of one of your templates, you can just run a find all inside this Twig directory and put in the name of the template, because every compiled template contains as a comment its original template name. So that's the way you could find your compile template inside the cache directory. Also, while you're writing a parser or a node type, you definitely need to add unit tests for them, because there are many situations which you may have not expected when you are trying to find your way around your own tokens. Yeah, luckily there is the node test case, which helps you create some test files consisting of a template file or a raw template data, and then the result you would expect after compiling. So you can check if a given twig string compiles to what you were expecting. Oh. Well, that's all for now. Yeah, it's been quite a lot, I think. So maybe it's good to answer some questions at this stage. Well, anybody? Yeah. Sorry, I can't really hear you. I'm not sure if there's someone who could, or maybe I could give a microphone to someone, or yeah, is that okay? It also helps other people in the room. Oh. Is this one on? Yeah. All right.
I was just asking, like, how were these plugs into Symfony? I know there's like Twig Bundle, Twig Bridge. That if you could kind of elaborate a little bit more, or what features, like maybe the caching of the templates and that stuff.
Right. Well, Symfony doesn't do much to enable Twig. Twig already has many things inside it to work. So at least Symfony adds a way to find templates by bundle name, controller name, and then file name. It has a convention for that, and it converts that source to a real file path. But loading files and even caching files is something Twig does by itself. You can only configure the cache directory, which Symfony does for you. So, yeah, and of course there are many Symfony-specific tags added. When you have the full Symfony standard project, there are, for instance, the recently added stopwatch tag you can use to measure the amount of time needed to render a specific part of the template. Yeah.
Can a block not have an ending? For example, you showed us in the example you showed us there was this is and the opening block conference, and without an ending. So a block can be without an end?
It depends what block you were speaking of. Was it the conference tag block?
Yes, the conference tag block.
Yeah. Oh, it should have ended. Was there a mistake in the code?
I didn't see, so this is why I'm asking.
Yeah. Maybe.
There wasn't an end conference.
No, sorry. Yeah. The thing is, you don't need to add an end tag or something. Some tags could just live on their own. So really, of course, you need to close this tag block by adding a percentage sign and an accolade, but there's no need to collect anything that is behind this block and then end it with, just like end for or end conference. This is not dictated by Twig itself. This is something.
Okay.
Yeah, all the token parsers add.
Thank you.
Small question about caching. Don't you know, does Twig provide out of the box some kind of mechanism to use not file cache, but maybe some kind of memory cache, etc.?
I'm not sure. No, I don't know.
Thank you.
Though it just uses the standard PHP stream idea. So if there's anything no, in fact, it just uses file put content. So if you have any stream handler defined, which puts it somewhere else, that's entirely possible.
So there is some kind of entry point that I can define and to use my own, yeah?
Yeah, well, you could just use the standard PHP stream way of doing things, but there's no way to, I think, to make a different call, right?
There is a way.
Yeah.
You can define your own cache storage.
All right.
So there is a way. I don't remember the name of this mechanism, but you can define your own storage for the cache.
All right. Well,
You just have to extend some, implement some interface and plug it into Twig.
I'm not sure if Twig does support this out of the box. Last time I looked,
Yeah.
it didn't, but I maybe with some external library or.
There's a cookbook about it.
Right.
So I've implemented it and I stored the cache in the data. I think. Yeah.
All right.
We can talk about this later.
This is in the Symfony cookbook, right?
Somewhere
Or
or
Twig
in the
cookbook.
Twig.
Right. All right. Well.
Last question? Okay.
Hi. Have a question about if there's any hints about debugging Twig templates. Maybe how best practices or something like this.
Yeah, you're talking about trying to find out why a template doesn't work for you, or
Why doesn't work, or how to find what variables is coming here and showing them and something like this.
yeah. There are some tricks to echo anything that is available right there, right somewhere in a template based on the context variable. Since the context is passed all around, it contains any variable that is available. You could dump it using the debug call dump function. I'm not sure. It could be underscore context or maybe just context, but it's possible to see what is available at any time inside a template. Again, you could also call any of these lex parse or compile functions on the Twig environment directly to see what would be the intermediate result of the compile process. Maybe something is going on there. But you could also just use xdebug to debug your template and step through each of the lines. Since these files are just inside your project directory, and you can set breakpoints at any time, it will just execute the code, and or you can check what's going on at any moment. Right? That's it. Thank you very much. Thank you. Please give me some feedback on joined in. Visit my site, maybe follow me on Twitter. I'd like to talk to you and enjoy your stay here. Thank you.